You see stuff like this online every single day, right? A simple comment, a review, a quick tweet. For you and me, understanding what it means is automatic.
I mean, we get it instantly. It's a positive review, they're super happy. But what about a machine? To a computer, that's just a string of characters and symbols. It doesn't get emotion, it doesn't get context. It just sees code.
And that really is the big question, isn't it? How do we get a machine that thinks in pure logic to understand our messy, slang-filled, and super nuanced human language? They don't exactly get sarcasm out of the box.
Well, that is exactly where natural language processing, or NLP, comes into play. You can think of it as the ultimate translator between human speech and computer code. It's the bridge between our world and theirs. Okay, so for anyone studying for an exam, here's the definition you'll want to remember. NLP is the science of teaching computers how to read, understand, and even derive meaning from all the text we're constantly creating online. It's how we make sense of all the digital chatter.
So how does this all work? Well, it's not really magic. NLP uses a specific set of tools in a very logical order. Think of it as a toolkit for teaching a computer how to read. Let's open it up and see what's inside.
From a bird's eye view, the whole process looks something like this. You start with the raw text, you break it down, you clean it up, you convert it into a useful format, and only then can you really start analyzing it. So let's dive into each one of these steps.
First up, we have tokenization. This is square one. Before a computer can even think about understanding a sentence, it has to be able to see the individual words. So we just chop up the sentence into a list of its parts, and we call those little parts tokens.
Next up, we have to do a little spring cleaning. See, not all words carry the same weight. Words like is, or the are super common, but they don't add a ton of unique meaning, so we get rid of them. These are called stop words, and removing them helps the computer focus on the words that actually matter.
I love this analogy. It really is like cleaning your room before you start a big project. You have to get rid of all the clutter so you can focus on what's important. The stop words are the clutter, and the meaningful words like phone and great are what we want to keep.
Okay, after we clean up, we want to group similar words together. One way to do this is called stemming. Now, stemming is the fast and, well, kind of dumb way to do it. It just crudely chops off the ends of words, like ing or ed, to find a common root. It's quick, but sometimes the result isn't even a real word.
Now, if stemming is the brute force method, lemmatization is the smart, sophisticated approach. Instead of just chopping off endings, it actually uses a dictionary to find the true root word, or lemma. This is huge because it understands context. It knows that the word better actually comes from the root word good. Stemming would never figure that out. It's slower, but way more accurate. So this is a really important takeaway, especially if you're studying. It's all about the trade-off. Stemming is fast, but rough. Lemmatization is slower, but much, much smarter. So the one you choose really depends on your goal. Do you need speed, or do you need accuracy?
All right, enough theory. We've seen the tools in the toolkit, but where do you actually see all this stuff in your day-to-day life? Let's take a look.
And the answer is pretty much everywhere. That chatbot that helps you track a package, that's NLP. Your search engine that magically knows what you mean, even with typos, NLP. Voice assistants like Siri and Alexa, you guessed it, they're powered by these very same techniques.
So let's take a super common example. You go to a website and you type this into the customer service chat. You're not using special keywords, you're just talking like a person.
Now, the chatbot doesn't just see the word order. It uses NLP to understand that the key ideas are help and order. It gets your intent, what you're actually trying to accomplish, and then it can give you a useful response. That's NLP doing its job perfectly.
Now, as incredible as all this is, NLP is not a perfect science. Human language is, well, it's tricky. Let's touch on some of the big challenges, and then we'll wrap this up with a nice summary for your exam prep.
Slang changes all the time. Emojis can have dozens of different meanings, and context is king. The word sick can mean you're ill, or it can mean something is really cool. These are the kinds of problems that researchers are still working hard to solve.
And this right here just says it all. How do you possibly teach a machine that lit means excellent, and that the fire emoji just reinforces how positive it is? This is what makes NLP so hard and so fascinating.
All right, if you only remember one thing from this whole explainer, make it this sentence right here. This is your perfect, bite-sized summary of what NLP is and the core techniques it uses. It's got everything you need.
And to make it even easier to remember those 4 key steps, just use this little trick. TSSL. Tokenization, stop words, stemming, and lemmatization. TSSL. It's a super simple way to keep that processing pipeline straight in your head.
And at the end of the day, that's really what this is all about. Machines don't have our life experience or our cultural understanding, but with the powerful toolkit of natural language processing, we're slowly, step by step, teaching them how to understand the world not in code, but in our own words.